So this video is on Integrated 3, Semester 2, Final Countdown number 3. So in this first problem, we're dealing with it looks like arithmetic series. So arithmetic is S sub n for the series. The sum is S sub n equals A1. Sorry, wrong. Doing geometric is equal to n over 2 times A1 plus A sub n. And we are going to need, we know our A1, we know our A sub n, but we just don't know what n is because we don't know what term this negative 83 is. So I'm going to use the A sub n formula. So that's going to be equal to my first term, which is 47. We are subtracting 13 times n minus 1. So I'm going to put a negative 83 in here. I get 47 minus 13 times n minus 1. I'm going to subtract 47 from both sides, so negative 83 minus 47. I get a negative 130 is equal to negative 3 times n minus 1. I'm going to divide by negative 13. I get 10 is equal to n minus 1. So n is equal to 11. Okay, so that means I am going to find the sum of the first 11 terms. So this is going to be 11 over 2 times my first term, which is 47, plus my second term, my last term, sorry, which is negative 83. So I'm going to go minus 83. And I'll put that in my calculator. 11 times 47 minus 83 divided by 2. And I get negative 198. That is our sum. Okay, so on 24. So this one, we want to find the sum. It's in what we call summation notation. This is geometric. So my geometric finite sum is S sub n is equal to A1 times 1 minus r to the n all over the quantity 1 minus r. Now, in this case, I have all my information. I just need to plug it in. So I need to know my first term. My first term, since this is an n minus 1, this 34 is my first term, but you can always plug 1 in to find it if you need to. So if I was to put 1 in here, whoops, that should be a 0.8. I would get 1 minus 1, which is 0. And 34 times 0.8 to the 0 is a 1. So I would get 34. So this is your A sub 1. Okay. This is my R. Okay. And again, this is my A sub 1. And I know we want 22 terms. So I am going to do S sub 22. Okay, S sub 22 is equal to 34 times 1 minus 0.8 to the power 22 all over 1 minus 0.8. And I'm going to put that into my calculator. And let's see. I am going to get 34 times 1 minus 0.8 raised to 22nd over 1 minus 0.8. And I don't need parentheses when I'm doing it in on the bottom when I'm doing it in this fraction form, but if you're not, you do need those parentheses. And so I get 168.75 about is what I get. Let me see if I change it to a fraction. If it's a nice fraction. No. So that is our answer. Okay. And again, let me make sure you see that that is a decimal there. Okay, so next problem, number 25. Okay, so this is a word problem that's dealing with an infinite geometric series. So we have a ball that's bouncing. It's launched 25 feet into the air and it rebounds 1/5. How far will it have traveled vertically in total when it stops bouncing? So what we need to remember when it's doing this, it's getting smaller and smaller and this keeps going forever and ever. But the distance to here and to here and to here and to here is what I'm going to be figuring out when I do my S is equal to A1 over 1 minus R. But I also have my downs, my downs, my downs, my downs. So I am going to take this answer and I'm going to end up doubling. Okay, I'm going to have to times by 2. Okay, now you can only have an infinite geometric sum if your R is between 0 and 1 in absolute value, and it is. So then I'm going to go S is equal to 25 times 1 minus 1/5, which is 25 times over 4/5. Okay, which is, if I was doing this on a calculator, 25 times 5 over 4. So I'm going to get 125 over 4. And let me just put in my calculator. So again, you could put it straight in your calculator. 25 over 1 minus 1/5. And I end up with 125 over 4. If I want it as a decimal, it is going to be a 31.25. But remember, I have to double my answer. Okay, so I need a times by 2. And so when I times this by 2, I get 62.5. On number 26, okay, another sequence. Find the first term of the arithmetic sequence. So how I personally would do this is I'm going to use the A sub n formula, but since I know my third term instead of my first term, I'm going to start with my third term, 8. And I'm going to go plus d, because it's arithmetic, times n minus 3. Why? Because that's what it will be if it's my third term. If I had used my first term like I did over here, okay, so over here, my first term was 47. So since I used my first term, I had an n minus 1 here. Okay. So now what I would do is take this right here, which is my 20th term is 59. So I'm going to go 59 is equal to A plus D, and then 20 minus 3. Yeah, this will find my D for me. So I'm going to subtract 8 from both sides, and 20 minus 3 is 17. So I get 17D. And when I divide by 17, I'm going to end up getting 3. So my D is 3. So I'm adding 3. So what we wanted was the first term. So what I'm going to do is I'm not going to rewrite my equation in terms of my first term. I'm going to use this term starting with my third term. Now I know my D is 3 and n minus 1, not n minus 1, I apologize, n minus 3, because this is our third term. Okay. So understand this 3 right here is this 3. And this being the third term is why this is a 3. 2 totally different 3s, just happen to both be 3. Okay, and so if I want my first term, I am going to go A sub n is equal to 8 plus 3 times 1 minus 3. And that's going to give me A sub n is equal to 8 plus 3 times negative 2. So that's 8 plus negative 6, which is a 2. And that's my first term. This is my A1. Okay. On 27. Okay. So on 27, this is the binomial theorem, where what you want to do is you want to take the power that you're raising the binomial to minus the term. Okay, let me color code. Let me start again. minus the term that you're looking for. And then you're always, always, always going to add 1. Okay. So we're going to get 5 minus 4 plus 1. And that is going to give me 2. So now I am going to take 5, choose 2, and then I'm going to have something to the power 2 and something to the power 3 because 2 plus 3 adds up to 5. Okay. And again, this 2 is the same 2 as the one I found here that I put here. Okay, so now my first term is W being raised to that power. My second term is a negative 4Z being raised to that power. And then I'll put this into my calculator. I'm going to do math. Okay. So I need my combination. So I'm going to go 5, choose 2. Times my W doesn't have a coefficient, but I have a negative 4. That's going to be raised to the power 3. And so I am getting a negative 640 W squared Z to the 3rd. And that is your 4th term. So 28, this one looks like we are doubling, okay, timesing by 2. So that means it's geometric. And they want us to write it in summation form. So first off, A sub n would be 5 times 2 to the n minus 1. Now, that's going to be in my summation notation, but I need to know what term I need to go up to put on top of my summation. So I need to figure out what term that is. So I'm going to go 81920 is equal to 5 times 2 to the n minus 1. And I'm going to do this math. Okay. So I am going to divide both sides by 5. So 81920 divided by 5 is going to give me 16384 is equal to 2 the n minus 1. You can log both sides, but I'm going to rewrite this in logarithmic form. So it's going to be log base 2, because the base is the base. In your exponential form and in your log form, they're the same, of 16384 is equal to your exponent. Your exponent's what a log equals. So the n minus 1, which is my exponent, is equal to my log. So now I'm going to go alpha window. And number 5 is log any base. The normal log button on your calculator is only base 10. So I did alpha window. And I'm going to go to log base 2 of 16384. And I end up with 14. So I get 14 is equal to n minus 1. So n is equal to 15. Okay, so now the whole reason I did that was to write it in summation notation. So that means I'm going to use my sigma. N equals 1 to 15. That's why I found that. And then my equation is 5 times 2 to the n minus 1. And that is summation notation. Okay, so this is our chapter 11 information of our rational expressions. So this one is kind of more like laws of exponents, okay? So when you're multiplying or dividing fractions, you do not need to get a common denominator. So I'm going to rewrite this 15x to the 5th, 5y to the 2nd. And when I divide by a fraction, I can multiply by the reciprocal. Okay. And now I can simplify. I'm going to look at my numbers first, and here I'll make it a little fainter. Okay, so looking at this, 5 goes into 15 3 times. I mean, I can multiply straight across, top with top and bottom with bottom, but I can simplify a little here. Then I notice that 6 and 3 goes into 3 once, and 3 goes into 6 twice. And then 2 goes into 4 twice. So my number is going to be 2. I can also take 15 times 4 and get 60 over 30, and 60 divided by 30 is 2. And then let me just do x to the 5th, y to the 3rd. And on bottom, I'm going to have an x and then y to the 3rd. We still need to clean this up. So since I have a y to the 3rd and a y to the 3rd on top and bottom, that's going to simplify. And then I have an x to the 5th over x, so that can simplify. My answer is going to be 2. My y's are canceled out, and when I have x to the 5th on top and x on bottom, 4 of them can cancel. I mean, one of them is going to cancel top and bottom, and I get x to the 4th, so 2x to the 4th. And that's your answer. Okay, these ones are a little bit more difficult. Okay, we have to factor. So let me start by factoring this. You can do box to diamond if you want. I am going to just do it this way. So I know I need a 3x and an x to get the front. The back is going to be a 7 and a 1. I'm thinking I probably want my 7 to multiply with my 3, because that will give me a 20, and then a 1. And I want a positive 21 and a negative. So there you go. So that is the top of that one. Okay. This bottom one here is going to be an x plus 5, x plus 7 times this right here. First thing I'm going to do is I can take a 2 out, and I'm going to get an x squared minus 25. So I'm going to have a 2. Now the x squared minus 25 is a difference of 2 squares, x plus 5, x minus 5. It's important you can notice that. It just saves you time. Okay, and on bottom, this I could factor out. Let me just, let's see, a 4 and an x. And I'll be left with a 3x minus 1. So that's what I'm going to get. 4x times 3x minus 1. Do not need common denominators. Now I'm basically going to try to simplify. So this x plus 7, this x plus 7, this x plus 5, this x plus 5, this 3x minus 1, this 3x minus 1. And be careful. You have a 2 and a 4, which we can reduce. So here, let me just write this. 2 times x minus 5, 4x. And so I can take a 2 from top and bottom, and I'll get x minus 5 over 2x, and that's your answer. On 31, we are going to factor. So I'm going to factor this. This is a perfect square trinomial. This is an x plus 3 squared. I'm going to write it as an x plus 3, x plus 3. This right here is a difference of 2 squares. I'm going to write it as an x plus 3, x minus 3. Okay, so let me just rewrite this problem. So this is going to be x plus 4 over x plus 3 times x plus 3. Okay, give myself some space. Minus, and I'm going to do this. I'm going to go plus a negative 7 so that I don't lose that negative. And this is an x plus 3 times x minus 3. Now I need a common denominator. So I am going to need to multiply top and bottom by x minus 3 over here, because this one didn't have an x minus 3. And the other side does have an x plus 3, but I have 2 of them over here. So I need 2 of them over here. And then I'm going to do my math. So x plus 4 times x minus 3 is x squared plus x minus 12. And then I get a negative 7x minus 21. And that's going to be over x plus 3 squared times x minus 3 if you want. And let's see, let's clean this up. So I'm going to get an x squared minus 6x minus 33 over x plus 3 squared times x minus 3. And you would want to check to see if you can factor the top, but a 33 is a 3 and 11, and that's not going to get me a 6. So that's your answer. 32. So 32, we are adding these. So I have my 5 and x plus 1 plus my 7 and x minus 4. I need to get common denominators. So I am going to multiply this side by an x minus 4 top and bottom. The other side, I'm going to multiply by an x plus 1 top and bottom. And so my common denominator is going to be x minus 4 times x plus 1. And on top, I'm going to get a 5x minus 20 plus 7x plus 7. So that's going to give me a 12x minus 13, not factorable, over x plus 4 times x minus 4. X minus 4 and x plus 1. And that's your answer. And that's the end of Countdown to final exam number 3.